Hi everyone. So in this video we have a high-level discussion of some strategies for recurrent neural networks to basically process and generate sequences that have variable sequence length. And so basically the input sequence length could be variable, the output sequence length could be variable. And think like one example application that's very obvious where this is useful is speech recognition and generation, right? So you would, the sentences have variable length, and you would need to determine when a sentence is ending and a new sentence is starting, and to generate, right? So a speech recognition and generation system, like in translations or in assistant devices that automatically recognize sentences and produce sentences, right? So this topic has implications even beyond the simple reason of recognizing and generating sequences of variable length. And because it has roots in theoretical computation or theory of computation, where in Turing machines you have this hold symbol that determines that this is an end of a sequence, whether this sequence is input or output. And if you want to read more about that, you could read about the hold symbol of Turing machines. And this was actually kind of one reason for the inspiration behind the first strategy that we explained, which is called self-delimiting neural networks, and it was introduced in 2012. And I think that's very interesting work that may open the door in the future for a lot of new kinds of recurrent neural networks. So the idea behind SLIM is basically to mimic Turing machines. You have this hold neuron, so a special output symbol that represents the end of a sequence. And actually they leverage that idea to train very large neural networks that could be trained for a variety of tasks. Like the same network can handle multiple tasks. And because the network has a mechanism to identify the start of a new sequence and the end of one sequence, it could basically have some kind of dynamic operation even during inference. So even not only during training, but during inference, it could monitor the change of the weights at the start of a sequence, and based on the weight pattern at the start of a sequence, it decides to only focus the attention or focus the inference on only a small part of the network. And in training, the same thing, focus on training only a small part of the network, right? So it's kind of like the human brain. You have this very general learning machine that can, based on context, decide to only focus on a small part and recall the memories related to that small part, both during inference and during training, right? So one disadvantage of SLIM or self-delimiting neural networks is that it becomes non-straightforward or not obvious for applications where the output of the neural network is not symbols. So think of it as if the output is real numbers, for example, in a regression problem. Then how would you have this special symbol? And one alternative to handle that is to have a separate output unit that let's say has sigmoid and cross entropy, and this output unit is 0, 1, Bernoulli output, right? So if it's let's say if it's 1, then this is the end of a sequence. If it's 0, then the sequence has not ended yet. So the advantage of that is that it could be applied to general recurrent neural networks, even if their output is real numbers, not symbols. Now, another strategy that has its own advantages is to add an extra output for the sequence length. So you predict the sequence length, and then you output the sequence. That has an advantage of realizing when you are near the end of the sequence, or when you are in the middle of the sequence, or when you are at the start of the sequence. So the recurrent neural network can leverage that to employ different mechanisms depending on where in the sequence are we. Right? So remember in a previous video, I mentioned this example of like, let's say I have a recurrent neural network that's processing videos to output trailers, videos of movies to output trailers. So it would need to know whether this scene is important or no for outputting to a trailer. It would need to know where in the movie, in the timeline of the movie, the scene lies in. So it could deploy different mechanisms, different learning during training and different inference mechanisms during testing, depending on where in the sequence are we. And that's an advantage of knowing a priori what the sequence length is, or predicting the sequence length can be advantageous. Right? It also has a statistical advantage in a sense that it really mimics the maximum likelihood principle of predicting the joint probability of the output sequence as well as the sequence length. So it's as if you have the probability of tau and then the probability of the output sequence conditioned on tau. Sounds good? In general, this one takeaway lesson to remember is that this has implications on the ability of recurrent neural networks to compute or to represent functions in general, right? So similar, if you remember at the very start of this section when we discussed networks with hidden-to-hidden recurrence, and we said they have theoretical guarantees because they mimic Turing machines, or they can simulate Turing machines. Here also having this ability to output a halt symbol or to predict the length of the sequence can have an advantage in terms of the expressive power of the recurrent neural network in terms of the range of functions that it can represent. And if you are curious or want to read more about the specific strategy of predicting the sequence length first, you could check that paper stated in the notes here on multi-digit number recognition. Thank you.